Hello everybody and welcome to my channel. This is a new video tutorial series of database. The database could be RDS, DynamoDB, or QLDB. In this video tutorial series I will teach you how database works and how to use my RDS with Blueprint plugin, DynamoDB with Blueprint plugin, and QLDB with Blueprint plugin. So now let's talk about database design. First, let's talk about the data structure. First of all, I would recommend you to read Algorithms by Robert Sedgwick and Kevin Wayne instead of just watching this video tutorial to learn data structure. Data structure is a huge and complicated science. It's the basics of all algorithms. And normally, a computer science student will need half a year to learn this in his college before learning algorithm instead of just watching a video tutorial. But this tutorial will just walk you through everything about data structure very briefly. Let's start with the simplest data structure, an array. An array is a list of objects that are defined in a contiguous memory. Every time you claim an array, you need to allocate a contiguous memory. It has constant size. Developers use memory offset to access its element, so access many elements will be fast. But if we want to change its size, we need to reallocate a new contiguous memory and mark the original memory as deleted. So, in order to create a variable length array, developers created another kind of data structure. We use a structure as an element in the array. We save the data with the next element's memory address in the structure, so that we can access the next element by accessing the data in the structure. If we want to insert an element into the array, we can just modify the element at insert position to the new element and link the element we are going to insert to the next element of insert position. But looping the array will need to access them one by one and in a single direction. We can add another pointer in the structure to store the memory address of the previous element. Then it will become bidirectional. If we make the next element address as an array so that an element can link multiple elements as next element, then it will become tree data structure. For example, a friendship network can be represented by a tree structure easily. Moreover, there are queue, dequeue, stack, as well as other data structures. But I will stop here because these are all data structures I will mention in the future video tutorials for database. If you want to learn more and become a better database designer, you should learn from the book that I recommended above. In programming, we use memory address to locate data. In database, as alternative, we use primary key to locate data. So, we change the memory address to database's primary key. This is how we will store a data structure in the database. Next, let's talk about relationship types. In reality, most relationships between data can be categorized as one-to-one, one-to-many, and many-to-many. One-to-one means the data has and only has one related data. For example, country to its capital city, email to its user account. One-to-many means that one data has many related data. This is also the most common relationship type. For example, country to all its cities, you to your friends. Many-to-many means many data has many related data. For example, books to tags. Identifying the type of a relationship will be the basic skill of database design. But it's totally about how you comprehend the data you need to store. I won't talk any more about this in this tutorial video. Now I will introduce a common way to store data for each of these relationship types. There are more than one way to store data of any of these relationship types. You need to design how to store data in your game by yourself. Let's consider the simplest relationship type, one-to-one. I will take country to its capital as example. You can see here there is two data tables, one for countries and the other one for cities. The ID column is primary key of both of the tables. What we need to do here is very simple. Add one more column in country table for capital and enter its capital city's ID in the cities table. Let's consider the most common relationship type, one-to-many. I will take country to its cities as example again. You can see here is two data tables, one for countries and another one for cities, the same as the last page. The ID column is primary key of both of the tables as well. What we need to do is instead of adding column in country table, we add a new country column in city table. We change the relationship into which country the city belongs to. Some developers may do this and they may add multiple columns for cities in country table. It's not a good design, even though it is doable in some NoSQL database. Many database services provide a feature called join, which you can use to combine the data of two tables. By using join feature, you can define one or multiple columns as foreigner key, which means it's primary key of another table. Then you can view two tables together. It's much more readable for humans. However, if you add multiple columns for city and country table, you can't tell the database to look for all columns that start with city and join the city table. It's not doable and it's not convenient for the future data analyzing progress. You may be curious as to why not just save the cities as an array in a column. Some databases do support saving a JSON object in a column. Some of them even support scanned data in the JSON object. But none or only a few of them support setting indexes for the data in a JSON object column. And this means that the query speed would be very slow. So in theory, we need to design our data table as flat as we can. We need to prevent saving any container data types like array, map, class, structure, and so on in a column. In database, these container data types are called non-primitive data structures, which also divide as linear data structure and nonlinear data structure. On the contrary, primitive data structures include integer, float, character, boolean. When designing a data table, we need to try our best to use primitive data structures only. Let's consider the most complicated relationship type, many to many. I will take books to tags as example as well. You can see here is two data tables, one for books and the other one for tags. What we need to do is create a third table for the relationship of books and tags. The first row is the relationship ID, the second row is books ID, the third row is tags ID. That's all. Thank you for watching.